Okay, the next session is going to be the climate session, which will be led by my colleagues, Dr. Ellen Dyer and Dr. Callum Munday. So I'd like you to invite you up to the stage and lead us through the session, please.
All right. Hello, everyone. I like that this is called, is this okay? The climate session. That gives us a lot of scope here. The sound is not good. Welcome to our there we go. Welcome to our plenary session on the search for clarity on future climate. Can we go to our first slide, please? Awesome. So I'm Ellen Dyer. I'm a climate researcher in the REACH program, and I'll be chairing the session with my colleague, Dr. Callum Munday. And we will have a wonderful panel of climate experts up here in a moment, and they will give us some interventions, and then we will have a discussion where we hope everyone will have tons of questions ready for us. But before we go into that, we will give you a little bit of a breakdown on REACH research and how we have innovated in some ways in climate and what things we have still to do. So we've brought together a panel of climate experts to discuss innovations in climate research. However, a critical part of this discussion revolves around impact. Is climate research able to respond to the need for information about climate risks in practice and support adaptation that might reduce vulnerability? REACH has included a big focus on understanding contemporary risk. In theory, this is what we can be certain is in the realm of possibility. Contemporary climate is already producing, next slide please, is already producing events that are a challenge to manage and to cope with. It's also clear that even these contemporary events can be a challenge to predict. In East Africa, examples of this include extreme rainfall in 2019, which was caused by a strong Indian Ocean dipole event, followed by recent prolonged drought caused by a triple dip La Nina event. How will the climate, its characteristic variability and extremes change in the context of increasing temperatures in the region? A big challenge to being able to answer that question and any questions about future change are the tools that we have available. We know that most models, especially those publicly available, are challenging to use because of their coarse resolution and biases in capturing historical climate processes that are really important for understanding and sort of capturing variability that we care about. This makes it challenging to work with a spread of possible futures beyond changes in mean characteristics, and especially for variables like rainfall. Next slide, please. I realize there's a clicker here and I forgot about it, sorry. Okay, REACH has approached this problem from an interdisciplinary perspective. The project has brought together a varied group of researchers, many of whom are in this room, and followed a risk-based approach, which is ideal for grappling with climate impacts. This has led us to question the way we have conceptualized key climate characteristics, conventions in space and time, and how to fill observational gaps and apply and use the best models to answer complex problems. We also have questioned how we interact with and produce information as researchers. For instance, we've deconstructed seasons to better understand processes that drive variability. This is key for understanding useful metrics like season onset, but also that onset is highly tied to seasonal rainfall totals, for example. And this information is really useful for understanding extremely wet and extremely dry seasons and why they happen. Also, examining different timescales has also helped to tease out links with water use behavior in connection to climate, and also has led to a possible explanation as to why users in different locations make different choices about whether they pay for reliable water sources during wet seasons. So this is an example of that. There was a question of why water users in Rwanda are making different choices than water users in Uganda who have very similar rainfall climatologies. I'm trying to understand if there's any connection to climate in this. And it seems that people who continue to pay, which people in Rwanda did during their wet seasons for safe water, live in areas with more extreme and intermittent rainfall during their wet seasons. Critically, this is a characteristic of future climate change in many areas, more extreme and intermittent rainfall. highlighting that this added urgency to provide safe and reliable sources of water. As well as rethinking temporal scales, we've been grappling with how best to work across spatial scales. And this is an ongoing challenge because to understand localized risk, people really do want information at fine scales that align with jurisdictional borders. But most models tend to provide information at much coarser scales. In REACH, we found it useful to both scale up and to scale down. And for instance, we scaled down in work with Dr. Mirante to provide support information for seasonal forecasts in the Awash Basin in Ethiopia by dividing the basin into distinct climate zones. This made it easier to determine which distinct drivers of rainfall variability there were in different parts of the basin and their lead times. However, in trying to understand the drivers of Ethiopian summer rainfall and how models reproduce this feature, we actually scaled up. So the Awash Basin there is that tiny point in the green box there. We scaled up to examine a co-varying region in the Greater Horn of Africa, and doing this allowed us to develop a diagnostic that captures the influence of both the Atlantic and Indian Ocean variability on rainfall in this expanded region and in Ethiopia. Now, a key part of explaining how large-scale climate impacts on local conditions is understanding regional climate and circulation features that modulate these influences. And now I'm going to hand over to Dr. Monday.
Thanks, Adam. So as climate scientists on the REACH Water Security program, we're very interested in the origins of droughts and of floods and understanding the sort of atmospheric configurations that you end up getting in order to produce these quite extreme events that we have. And that process is really important if we want to be able to predict those droughts, both on timescales from seasons, but also on climate change timescales. So really, in order to understand the origin of these things, we need to have a good idea about how the regional climate system, how the atmosphere sorts itself out at times when we have drought and when we don't have drought. One example of this that we did in East Africa is this thing called the Turkana jet. So it's not a fighter jet. This is in fact a very fast wind system, which starts off, it originates in the Indian Ocean, and as you can see by these arrows here, goes all the way through Kenya and into the interior of Africa over the Congo Basin. And in doing so, it carries all this water vapor, which starts off its life being evaporated off the Indian Ocean, and transports that water vapor through Kenya, through East Africa, and into the rainforests of the Congo Basin. And one thing that we found out during REACH, which is especially interesting in terms of drought, is that the faster these winds go, and the more water vapor which gets transported away from East Africa, the drier it tends to be in East Africa. So during REACH, what we're trying to do is understand what this feature was doing. But we had a bit of a problem. So this is a global map of upper air observation stations. And these observation stations, twice a day, every day, they release these things called weather balloons, which you fill with helium, and they go from the surface all the way up to the top of the atmosphere. And as they do so, they measure temperature, humidity, and wind speed. And these bits of observation are really useful for us because they help constrain our forecasts, they help work out how good our models are doing, and they help interpret how the regional climates work. And you can see some, on the subject of inequalities, you can see some pretty big inequalities in this map here in terms of Africa. So obviously, you can notice that in the UK, Europe, and North America, there's many more of these upper air stations which supports their more accurate forecasts of weather. But also, I'd like to point out this bottom row here, which is Antarctica, which the population of Antarctica is 5,000 people. 500 million people live in this Greater Horn of Africa region, and there's 2 stations operating there compared to 15 in Antarctica, which is something that we want to change. So, back to the Turkana jet, the problem is pretty pressing. So these pink squares here are the existing upper air observations, and the orange shading is there where the jet winds and the water vapor transport is greatest. And you can see basically the jet bisects the region where you actually have observations. So a really exciting part of the REACH project for us was to be able to go out to this blue star here in Marsabit, which is near Turkana County in Kenya, and go and do this month-long series of observations. And as part of these observations, we released these weather balloons every 3 hours for a month, so through the day and night. And this is Dennis, who's somewhere here, and Joffrey from the Kenyan Met Department, who are releasing a balloon at 3 a.m. and looking remarkably happy about it, which is great. So why are these observations important? Part of the reason is to be able to improve our models and test our models. So this is in the hill just above the weather station in Marsabit where we were doing our readings from. And these are 2 wind turbines, which used to be standing up. They were installed in 2005 here by a French company. And they installed them on the basis of model data for how the wind should be. But the problem was that the model data was slightly wrong, and actually the wind was much faster than they thought, so the turbines were generating way too much power for the grid, and after only 2 years of operation, obviously this is a great investment putting these turbines up, after only 2 years of operation, the locals had to pull them down because they're generating too much power. So this is a big problem. So this is a bit of a complicated graph, but on the x-axis here we have time of day. So this represents every 3 hours that we were chucking up a balloon. And then on the y-axis, we have the number of days. And the lines are showing the number of days we had this really fast wind and lots of water vapor transport. The black line here is what we actually observed in Kenya. And then all these other lines are different model versions of what we think happened. And the grey one is particularly interesting because this is the default model which the UK Met Office uses for weather forecasts in East Africa. And you can see that it gets things pretty substantially wrong. And the field observations in this case were really important in showing how wrong the model was, but then also in justifying creating these extra lines, making different models which might improve the situation. And one really important thing that we hope to do as part of this project is not only to be able to test models now, but also to justify an expansion of these observational networks across East Africa, so that East Africa looks more like North America in this figure. So I'm going to pass back over to Ellen now, who might chat a bit more about that.
Thank you. Yeah, so the importance of this kind of sustainable partnership to collect data, but also to use data and to create impacts has been highlighted in another pillar of the climate research, which has developed as the project has progressed. And this is understanding how climate research can have an impact in practice. And one aspect of this has been exploring how and what climate information is actually being shared with people who have to make climate-dependent decisions. We've done a mapping exercise with the meteorological and water sectors in Ethiopia that has highlighted how key individuals share and transform climate information in a network. And there's a simplified version of this on this slide here. So each point is a person or a source of information, and the arrows show who's sharing information with who, whether they feed back to each other, and who's really key in this network. And doing this exercise has highlighted what information is being shared. Most of the time, this is short-term forecasts, seasonal forecasts, and historical observations, rather than long-term projections. And that there are still definitely a lot of one-way pipelines of information. It's also highlighted that there are critical skills and infrastructure gaps that aren't being addressed. This is in part because a research impact pipeline that we've sort of commonly been using hasn't really prioritized local ownership over research, but rather local uptake of research done by external actors. And I can only really speak for climate science, climate services in making that statement. We've been working with local scientists to create tools specific to their defined questions and applications, and trying to make this an open source and a skill building exercise. So it's not something that we own, it's something that can keep being built on, and it's really about the human skills that can be passed from person to person. But this exercise has really highlighted how big a gap there is in doing this in current research collaborations. We've also found that there's a real discomfort among information providers in being implicated in decision making. So information tends to be shared without guidance, meaning that those who are inevitably making decisions and are impacted by the climate are also those who have the least expertise with the information to make those decisions. So this has raised a question of what climate information communities and individuals have access to, and what they're able to use in their decision-making in practice. And this is currently being explored across the partnership using social research methods by the Reach Wiser project and team who are in the room. So in summary, we think that working towards a better understanding of key climate processes that will determine the characteristics of change, along with an understanding of the human side of climate research and climate impacts, are integral for managing a changing climate. And we've set some discussion questions for our session today. And what I will do now is introduce our panel, one by one, and ask them to come up to the stage, and everyone will give an intervention, and then we will move to a group discussion. So first, I would like to invite Professor Daniel Alago, who is the director of the Institute for Climate Change and Adaptation and a professor of geology at the University of Nairobi. His research has focused on quaternary and environmental geoscience, and he leads the REACH program in Kenya. Professor Alago has also been a lead author on the 4th and 6th IPCC reports. Next, I'd like to welcome Dr. Louise Wilson, who is the Climate Science Advisor in the Research and Evidence Directorate of the Foreign, Commonwealth and Development Office, where she advises on climate risk assurance for the UK development programming. Louise is on secondment from the UK Met Office, where she's a climate scientist in the International Applied Science and Services Directorate. Next, I would like to invite Dr. Rachel James, who's an associate professor in climate science at the University of Bristol. She led on the development of a climate model evaluation hub for Africa as part of the Future Climate for Africa Consortium and Launchpad project with colleagues in African universities, and Rachel is currently leading the Salient project designed to explore new ways to communicate future climate change in Africa. And last but definitely not least, Patricia Nyunguru is a climate scientist at the Kenya Meteorological Department. She is a founding member of Climate Without Borders, which seeks to improve public understanding of climate science and policy, and a member of the AGNES Expert Support Group for the African Group of Negotiators. And Patricia is currently the IPCC focal point for Kenya. And I'd also like to invite, even though he is not here, Dr. Wilfried Pokamamba, whose visa did not arrive, but I will share an intervention from him during the discussion. He's a senior lecturer in the Department of Physics at the University of Yaoundé 1, and he's a member of the Climate Model Benchmarking Task Force for CMIP, and he is on the scientific committee of the Groupe d'Experts sur l'évolution du climat en Afrique centrale, an IPCC-like scientific support body to regional negotiators under the UNFCCC and IPCC. So, first I would like to hand over to Louise for her intervention, and we have a supporting slide for Louise. Please go ahead.
Thanks, Ellen, and thanks, Callum, for that really interesting overview of all of the great science that's been happening under REACH. And thanks also to the conference conveners and to my fellow panel members for this opportunity to share a couple of reflections and thoughts on meeting the needs of adaptation science from the perspective of FCDO, who is a funder. So FCDO is a merged organisation. We undertake development programming as well as policy and diplomatic engagement. And our evidence needs to support all these activities really centre around informing adaptation action globally, and that's in support of the UN Sustainable Development Goals. And we do this either directly through programming as well as through capacity building, which is to support adaptation action predominantly in developing countries. And I'm sure we're all aware that the latest IPCC reports are really clear that with every increment of warming, our adaptation options are becoming more and more constrained. And we know that adaptation implementation is not occurring at the scales or the speeds that's needed to meet the scale of the climate challenge that we face. And so we really need more of this kind of really interdisciplinary research and evidence that can inform our adaptation options in our race to build longer term resilience, as well as to inform our options for the challenges that we face right now, living in our changed climate. And this research really needs to be needs-driven, and it needs to be action-oriented, and I'll talk a little bit more about that in a second. And this is to really enable swift implementation. And one of the key challenges around this, amongst others, is to build the capacity, both of those carrying out the research, as well as those using the evidence, and Ellen just mentioned that before. So of the many, achievements and valuable lessons that we take from programs like REACH, from other programs that you might have heard of, like Future Climate for Africa, etc., is really the demonstrated value of deep and sustained engagement to build these solutions for a resilient future. And by deep, I mean both in terms of the range of actors that are involved in the dialogue, in the conversation, as well as depth across disciplines as well. So not just the climate scientists, speaking as a climate scientist, but also crucially, the insights from our social scientists as well. And this is really about fitting climate science with social research and pioneering kind of new, innovative ways to undertake this engagement. And that was really exemplified, for example, through the Fractal program in Future Climate for Africa, which some of you may have heard of, which held living labs. And this brought together researchers with government officials as well as local communities. And the aim was to really develop locally led options for adaptations, and to really get an insight into the complex kind of realities under which adaptation decision making has to take place. So there's no question at all that REACH has been a really successful program, and under new programs that FCDO is funding, such as the CLARE initiative, we're really looking to, not prioritise, what is it called? When you consolidate or learn from these predecessor programs and really bring in, the best of what we're able to learn and keep pushing the envelope forward. So to briefly give you some background on CLARE, for those who maybe don't know that much about it, CLARE stands for Climate Adaptation and Resilience, and it's a £110 million framework research program on climate adaptation that aims to enable socially inclusive, which includes very much gender and the most marginalised people in our communities, as well as sustainable action to build resilience to climate change as well as to natural hazards. It's jointly designed and funded by the UK and the Canadian International Development Research Centre. And it prioritises long-term commitments, so the program goes over several years and has a really strong principle of partnership, which we've already heard from the earlier session about how critical that is to actually, bridging these critical gaps between adaptation solutions and actual action. So projects worth about £50 million are already underway, and these are taking place in about 26 nations across Africa and the Indo-Pacific. And they span everything from inclusive urban resilience in South Africa and the Philippines, through to flooding along the White Nile, and the use of artificial intelligence in Bangladesh. So I thought just a couple of takeaways and then a question that I'd like to share. We've seen, the value of this really deep and sustained engagement to develop feasible and locally led adaptation options. And we know that we need to act now, that there's no time to waste when we have to act across scales and between actors as well in order to build a resilient future and sustainable development for all. So how can funders such as FCDO meaningfully ensure programs are needs driven by the people and communities they are meant to serve? Thanks.
Perfect, thank you. Now we'll hand over to Patricia.
Thank you very much. And from listening to Louise, it's very likely that a lot of what we will end up speaking about just amplifies what each and every one of us has talked about. So my work focuses a lot on the interface between science and policy and practice. And so my intervention will address that a lot. And one thing that I feel is a key innovation in managing risks in Africa in the light of changing climate is integrating the human face. So a lot of research in the past has been done, but how do we make that research more actionable at the local level? And one way to do that is to work with the indigenous communities, for example, who are one of the most vulnerable to the impacts of climate change, and who already, throughout years and years of adapting to changing climate, can offer up solutions for us to be able to build on and leverage on. So within the meteorological department, we do our best to work with communities to be able to co-develop with them solutions to the problems that they intrinsically face. So for example, at the seasonal level, when we provide seasonal forecasts, we sit with them. They have their forecasting methods, which in the past have been dismissed, but we see the value in bringing their knowledge and combining it with what we have. And this has served to increase the buy-in of the scientific forecast that we provide. And so we found that this has greater impact as opposed to if we came to them with a scientific forecast fully and shoved it down their throats in a sense. And then something else that Louise also mentioned is the value of interdisciplinary research. So we pretty much have established that climate is changing and the variability, for example, is increasing. But what does this mean from an economical point of view? What does it mean from a heritage, culture, social point of view? So if we are not able to demonstrate, for example, what this means to a certain community or a certain group of people, then it's very difficult for us to be able to help them to adapt to the changes that we see. So interdisciplinary research is very key in that case. So I was in a meeting about 2 days ago where we were looking at how best, for example, the IPCC can be able to support countries or policymakers in developing response measures that are context-specific. And one thing that came up is, for example, adding a compendium of case studies of adaptation practices that have worked across the globe. And what we thought is there are very similar situations that countries face. There could be governance issues that are similar across various countries, economical situations, and even climate variability. So if a policymaker can be able to pick something up and look at what was the cost of implementing this adaptation action, did it work or did it not work, then it provides them with the opportunity to pick the best one and then apply it to their local context. So that was something that we saw would be very useful. Now the question is, how do we consolidate all that? And an innovation that someone talked about was the use of artificial intelligence. So we live in a world where we have to deal with artificial intelligence, and if we can leverage it to work for us, then that's a key takeaway. So can we use artificial intelligence, for example, to assess all best practices of adaptation across the world and put them together and then present this to policymakers at different levels to be able to use to apply? Something else that is also in terms of innovations to deal with climate risks is innovative financing models. We've talked a lot about finance and how a lot of adaptation projects in Africa, for example, are very project-led. And so at the end of the project, what happens? Do we have sustainability? And I like that Rich incorporated that into it, and it's very interesting that 2 years to the end of it, they already started thinking about exit strategy. Someone mentioned, how about we do crowdfunding or crowdsourcing of financing for adaptation? And this allows us to tap into philanthropies, to tap into individuals, who may be able to support if they do know that there exists an opportunity to crowdsource financing. And that was a very interesting thing that I feel would be also useful in supporting managing of climate risks. And then innovative leadership. And in innovative leadership, had an example of a project that was done in Nairobi in the informal settlements, and it was focused on heat. So in order to get the communities to be able to take in climate information or climate services focused from the Meteorological Department, we worked with champions within the community. So it's local people who have a wide reach, who are known by the community members, and therefore they are able to be believed, as opposed to if a scientist who they've never seen before comes and tells them that it will rain tomorrow. So innovative leadership in the sense that we do not rely on conventional or traditional leaders, but we create leaderships or champions within whatever communities we intend to work in. And finally, I'd like to speak a little bit about challenges that I feel exist in dealing with or managing climate risks. And one thing is political cycles or election cycles. And the scale at which, for example, climate projections exist goes beyond the political cycles. So if we are encouraging, for example, politicians within one cycle to deal with environmental concerns and climate change, they ask the question, how, by the time the impacts you're talking about appear, I will be out of office and it's no longer my responsibility. So how do we deal with that? How do we make sure that we are able to provide information on impacts of climate change at a time scale that allows different political regimes to act on? And then another challenge is, I feel there could be improved understanding of the cost of inaction in terms of climate change, and also better understanding of the benefits of action. So if we're able to attach a monetary value, for example, to a business in terms of if you act now, you save this amount of money within the next 10, 15 years, then this, in my opinion, would move even businesses, even small-scale organizations to be able to act to safeguard their own economies, which at scale contributes to climate action. And so the question that I have, which partly has been dealt with, is on sustainability. So how do we ensure that response measures to climate change, for example, go beyond the project cycles? So if the project ends after 5 years, do we up and like the windmills we saw? So what happens after that? So I think that's a question that we need to start looking at how to address. Thank you.
Great, thank you. I'm going to interject on behalf of Dr. Wilfried Pokamaba, who is not here. But he had some suggestions for innovations that he thought have been made in the recent past that we should learn from. And one of the things that he noted is that we've moved from large research programs focusing on particular regions to more inclusive initiatives like WISER, Future Climate for Africa, and CLARE. These have specific case study locations, but there are many of them, and so it means that we can have a broad view of what's happening over the whole continent. And along with this broader view, the physical and social dimensions are increasingly being integrated simultaneously into projects. The other thing that he wanted to note is that capacity building is extremely important, and there are examples of really good initiatives. One is WASCAL, which is a capacity building initiative that has opened a hub. So there are master's and PhD courses, but based at centers in African countries, which was moved from being in Europe. So there's sort of more of a South-South dialogue in that sense. And then a challenge that's been echoed already is the sustainability of funding, including a strong commitment to local funding. Linked to this sort of preponderance of external funding, the prevalence of a top-down approach with all of the known limitations, and effectively taking into account local realities and needs is quite problematic. And then the other thing, which sort of relates to reach in a way, is that an inclusive approach to research is really important. So understanding things from a systems perspective. So for example, in Central Africa, understanding the climate ecosystem, water society links is very important, especially for water security. However, it's sort of rare for projects to take into account the whole chain of processes that would be required to understand and solve problems. And some suggestions for things that can overcome this. Wilfried had an example of an event called the One Forest Summit in Libreville in February this year, where researchers and policymakers came together to discuss these issues and create a set of research questions for the region for people to focus on. And some of the interesting solutions from this meeting were also to create 2 new initiatives, which is a science panel for the Congo Basin and the Congo Basin Climate Science Initiative, where experts work with policymakers on a regular basis to try and answer these research questions. So now I will pass on to Professor Daniel Alago for his intervention.
Okay, thank you very much. Yes, so I'll try to be short and maybe pose my question at the onset. Because we had good presentations from Ellen and Callum, but what really strikes us is that there is a dearth of correct data, or just a dearth of data. And here we are, all of us, really, expounding on documents, talking about adaptation, talking about water security, but we are really anchoring them in a mist about things that we do not know. So my big question is then, how do we actually answer this question of insufficient data once and for all? And in fact, weave it into the adaptation process so that as we seek to follow particular adaptation pathways, we have directions that are given by what is already available, but we also have the flexibility to change those pathways given new information. So we do have a lot of new tools or existing tools, but that have been refined that we can use. For example, remote sensing tools. We can use these, and I'm going to focus on groundwater as an example. We can use them to map out our recharge areas, nowadays to high resolution. And these are important in terms of implementing adaptation options such as managed aquifer recharge, because we do now well understand that groundwater is a buffer to the huge climate variability that we see in the tropical areas, and in particular in Eastern Africa. So we can use this information to store our water underground, remove it out from the vigorous high-energy hydrological cycle, and use it for periods when we have drought and other things like that. The second thing is that when we're talking about water security, you're looking at surface, groundwater, even rain itself. We can harvest rainwater directly, and these are options that should be looked at. There are technological solutions that can be applied at scale, like desalination has improved in many ways, but it is still very expensive, and it may still exclude many poor and vulnerable communities if options are not taken to consider that. We can also then look at rivers and lakes, but we have a problem here because there's a very high variability. What we see in the current situation is, based on, say, the mean flow of a river, what we see is plus or minus 50% of that kind of variability within a season. It's going to amplify, and it is amplifying under climate change. And as you've seen the intra-seasonal-ish aspects where you have many, many more dry days, very, very heavy rainfall, all of these are disadvantageous to having reliance on a surface water system. But for the groundwater systems, the very heavy rainfall that we expect, highly intense rainfall, is actually very beneficial to a groundwater system. It results in high recharge of really good quality water. And in areas like in Tanzania, there's the Makutapora well field where we see that a period of a couple of days of very intense rainfall really recharged the aquifer in what would have been a 40-year period had rainfall not been that intense. So we can see the real benefits of that. And then I think the other thing about the data is that instrumental data in this region is very short, going back maybe at most 100 years. We have, and you saw the big gaps in data gaps. We can go back to the paleoclimate record, and I want to talk a little bit about the Lake Chala record, and which we published a paper just a couple of weeks ago in Nature. Now, this earlier to that, there's a paper that said, well, was talking about the East African climate paradox, and I think she was an author in that particular paper. And they said that the rainfall season, March, April, May, is going to get less rainfall as we go, and by 2030, the October, November, December rainfall is going to take over as the main rainfall season. What we see from our record from Lake Chala, which is a 75,000-year record, is that between 75,000 years ago and 11,700 years ago, right at the start of the warm period, the Holocene, the relationship between temperature and rainfall was positive. As temperature increases, the rainfall amount increases. What we then see is that there's a reverse in that particular relationship, which is centered on a mean annual temperature of about 23 degrees centigrade and CO2 concentration of about 250 parts per million by volume. Now, what we interpreted it as is that as the atmosphere gets warmer, its demand for water from the ocean, as evaporated water, gets higher, and then it's so high, it becomes so greedy that it doesn't even digest what it has, so it stops forming rainfall. So we expect that these drier periods are going to continue. And we need to kind of take advantage of all this data, and we need it much more on the continent. Just maybe to finish off, we had this issue of the rising lakes in East Africa from 2010, and they continued to rise until 2020. The scientists were on the forefront of trying to understand what was going on. But of course, we need resources. Without resources, we are very poor. But here, the governments were saying, yes, we need an answer, but nobody provided any resources. So by the time that it became an issue that was now impacting on the economy to the scale where governments now said we need to act, it was also a little bit too late to be able to discriminate the issues that were contributing to that rise in the first place. So it is also important to have scientific action come in very early so that we are able to, understand and discriminate and deal with the situations effectively. Lastly, and it's very important, we need to deal with manage adaptation, taking into account the extremes rather than the mean values. Mean values mean nothing to us. Like for us, the diurnal fluctuations are so high that what we say is, how hot is it going to be in the middle of the day, and how cool will it be in the middle of the night? An average value in Nairobi doesn't mean anything to us. So it's a point at which there's no fulcrum. So we need to deal with extremes. And for policymakers, this is important because some kind of redundancy has to come into the system. How do you deal with drought and flood at the same time for particular infrastructure, etc.? Let me stop there. Thank you.
Thanks for solving our atmospheric bias as well. Now I'll head over to Rachel.
Thank you very much. Thank you for having me, and I'm looking forward to reading that new paper. It sounds fascinating. I want to talk about a challenge. I'll start with a challenge and I'll mention some innovations that I've already set out to address it. But this is the challenge of how we use model data, and particularly these long-term future projections, to try to generate understanding of what might happen over the coming decades in the real world. And to explain this, I want to take a kind of hypothetical and simplified example. So if we imagine a water manager in Malawi who's responsible for managing resources in a river basin which has hydropower, irrigation, important wetlands, and then, of course, important implications for domestic water security. He might have questions about climate change. How will rainfall change in a warmer climate? Will there be enough water in future for both hydropower and new irrigation schemes? And in this context, as climate scientists, so like many of us, can kind of step in and offer to provide
information, perhaps alongside our hydrology and water resource research colleagues. And we have climate model experiments that run into the future. However, using them to provide this information is not straightforward. As in many African regions, we find that some of the models suggest it's getting wetter in future, and some suggest that it's getting drier. And so when we decide to provide information in this context, we have to make lots of difficult choices about which models to use, how to analyze their data, and how to communicate the results to our water manager. And the choices that we make have really important implications, because if, say, this water manager is expecting it to get wetter in future, and in fact in 20 years' time it's become drier and there's a dominance of drought, the decisions that he's made could waste money, right? He might have invested in irrigation schemes and there's not enough water for them, or actually, you know, together we could have led to an increase in water insecurity in the river basin. So this kind of information is really important, and I think this challenge is not unusual. And it's not specific to African countries. All around the world, we're struggling with this thing of how do we use this uncertain model information. And I think one thing we need to do is stop thinking of this as a translation of research challenge. This is a challenge for new research. It's not something that we can do just at the end of a research program. I think the REACH program has done a great deal to kind of address this challenge through really exciting research, trying to understand current risk, and to look at these challenges around time and space and different scales of information. And I think that there are two other areas in which we can really work to address this challenge. So the first one is about reorientating the way that we do the climate science. So it's not led from the models, but it's led from adaptation. As climate scientists, we kind of can have a tendency to kind of cling to our models, but we need, and you know, every climate scientist tends to have their favorite set of models, but we need to integrate all of the information that we have available, all of the sources of evidence, right from different model ensembles, from observations that are available to paleo evidence, and integrate this together. We also, I think, shouldn't be afraid of using expert opinion. I think climate scientists often feel that kind of reaching for expert opinion about the future is scary because you know, it can feel unscientific. But every time we present a graph showing our climate model results, we're choosing which models to include, right? So it's still an expert judgment. And I think we can do better to use our expert judgment to supplement the model data and the observations. The second way in which I think we can address this challenge is through bringing in insights from psychology and risk communication to look at how we communicate about the future. Often within many of these interdisciplinary projects, we talk a lot about how difficult it is to communicate across disciplines, how difficult it is to communicate about uncertainty. And there have been some really exciting innovations around this. For example, instead of just using a map or a graph with complex quantitative information, using narratives to communicate multiple different futures to decision makers at the city level. For example, in the Fractal project that Louise mentioned earlier. And this is a really exciting opportunity to communicate in a different way that might be more engaging, more understandable, and more tailored to a specific decision context. And I think now what we need to do is actually do more evaluation and more testing of ways of communicating. So taking alternative approaches to communicating about the future and then asking our colleagues about what that meant to them. What did they understand from the information that we provided? Is it useful? Is it interesting? Is it engaging? Is it something that they would pass on to their colleagues? So those are the kind of two main areas. One is kind of reorienting the climate science, and the second is bringing in communications research. And so the question that I want to pose is perhaps what do others think that we can do to better address this challenge of understanding future change in the real world, and particularly perhaps around the timescale issue. So Patricia mentioned already this challenge that often in climate change impacts research, we look, say, like 30, 50, 100 years into the future. And this is far beyond the timescale of an election cycle. And for many people, it's really difficult to plan for more than kind of 10 years ahead. So how do we provide better information about kind of the next 5, 10 years to be more useful for decision making on those timescales? Thanks.
Thanks very much, Rachel. Should we go to the audience?
Yes, we're having time challenges, so we're going to hold these questions that everyone's asked in our minds and also ask for more from you. So we might try and take 3 questions and then have a bit of a round-robin discussion. Would anyone like to ask a question to the panel or give us a solution to any of the challenges that have been raised?
One hand there. Let's go that one first. That's you, yes, yes.
Do we have a microphone?
Yes.
I can repeat it. Thank you. And then Dr. Salahi.
First, just an observation, to remind ourselves that for some of the processes, anthropogenic signals are still stronger than climate signals, right? Some of the processes. Yeah, one specific question maybe. So what I understand is for climate change adaptation, to be very effective, the contextualization is very important, right? So because when you talk about people, different livelihood groups, so they have different, differentiated risks and vulnerabilities to climate change. So we are trying to integrate climate science with, people, so how they would benefit or disbenefit people. So I mean, do you think it's important to, basically link climate science to specific risk and vulnerability, and contextualization in that sense will be very important. We are talking about leaving no one behind for sustainable development goals. So in the post-2015 agendas, so there are a lot of overlaps, like climate change adaptations, SDGs. So we have a lot of commitments in Bangladesh, everything to be met, and most of the targets to be met by the end of 2030. So one thing that I find missing is how we can jointly achieve this climate change adaptation and SDG goals and DRR goals. So I haven't seen much discussion on this in the climate change adaptation discussion.
Thank you.
Thanks, Robert. I think we'll stick on those 2 questions for now and then pass over to the panel to answer whichever ones they see fit, or their own questions if they want as well.
Perhaps on Professor Salian's question. The issue of contextualization and differentiated risk, I have strong opinions about that, but I might throw this to Louise and Patricia, actually.
Do you want to go first?
Okay, yeah, I can go first. So yeah, thank you very much for the question, and thanks also for highlighting, you're absolutely correct that contextualization is everything. It's very clear that you know, adaptation is not a one-size-fits-all or even a one-size-fits-most. Some of our panel members, Patricia, I'm sure you'll talk a bit more, but you talked about how, you know, it's really essential to have the buy-in of the people for which, you know, the adaptation action is for. And adaptation is for people. We really must remember that. And so those people and their voices must be part of the discussion about what is that community's aims, you know, and goals, and what does adaptation look like for them. And for different communities, you know, that engagement looks different and will require different amounts of resources, particularly for, you know, some of our most marginalised people and people who are really disempowered and who don't have pathways to have their voices heard as part of that discussion. We just have to put in the hard work, I believe, to do that. There's no easy way to do that. I think before, Patricia, I let you come in, you also mentioned about, you know, how do we jointly achieve some of our sustainable development and disaster risk reduction goals. And that really is, you know, a global challenge, and which I don't have a solution for, but I just wanted to link it in that, again, you know, it's about building a shared vision of what, you know, adaptation looks like and what it is that we're aiming for, and bringing everyone along on that journey so that we can hopefully get there together.
Yeah. So I'll use an example to kind of answer your question. So in Kenya, there's a World Bank funded program that currently is going to ward level to look at what are the risks that each of these regions face. And so it's different across all the wards. And it also touches a little bit on the question on collaboration. So there's scientists who are part of it, who provide the projections. And then we have people in the social space who look at what are the underlying causes of vulnerability within this particular ward that is different from another one. And then after identifying all those things, then they co-design adaptation options. So it is very, very specific to their needs, and even across a very short distance, the adaptation responses are very different. So I think that approach where we collaborate with everyone, all of the stakeholders, and then we contextualize completely to the lowest level possible is a solution to that. Yeah.
Thanks very much. I was thinking maybe, Rachel, you're a good person to answer the question on how the private sector can talk to reticent academics who prefer to be in their ivory towers.
Yeah, it's a great question. I mean, I think it's brilliant that some of the emphasis from funders has moved towards research into action, research into impact, with REACH being a good example, which kind of allows us to, and encourages us to collaborate with people outside of academia directly in a research project. But yeah, I think part of what I'm hearing is an emphasis on kind of also learning and kind of harnessing the expertise of independent consultants alongside academic researchers, which is such an important point. And I'm not sure the best way to facilitate the collaboration, but I'm enthused. Perhaps the Adaptation Research Alliance is a good network for that, which many organisations, including universities and practitioners, are part of. So I think sometimes it's hard to know sort of which network to use, right? Because we're working across kind of SDGs, water security, climate, adaptation, resilience communities. But I think that would be perhaps a good network to focus on it for this particular challenge.
I mean, just on that point as well, I think one thing is that we have to absolutely have those discussions. I mean, having talked a lot about how we don't have any data, there actually is a lot of data out there, and it's probably the scientists who can actually give the best interpretation and navigate the way through that data. So even if our knowledge is imperfect, I think it's important we have those discussions. So we might choose model X instead of model Y. and that's something that we could help with. But I'm not sure exactly under what guise that could happen.
I was just going to, oh, go ahead, Louise.
Could I just briefly come in on that as well? I think as funders or as you know, as programmers, we can also encourage interdisciplinarity within programs as well, which facilitates and enables, you know, the climate scientists who are looking at the climate data to come together with experts from other fields and together kind of build that shared language and shared insights about how that works. I think that's something that increasingly, you know, we're seeing more of. And it comes back to that, something you said, Rachel, about the capacity of both, you know, decision makers who are ultimately, you know, the aim is for them to use the information, building their capacity to use it, but also for the researchers to ensure that the research that they're doing is tailored and meeting the needs of those decisions. And so that requires the researchers to understand that decision context, and that will be much broader than any one individual discipline.
I was going to ask about the story that, Dan, you were telling about the lake levels and research not being done quickly enough. Louise, you asked about how do we do a needs-based approach? Like, how do we do that in practice? But we've also talked about how timescales for funding are a bit too short. But in your case, Dan, it almost seemed like you would have needed a reaction quite quickly, and that is a question of, that was a need, that question needed to be answered. Why do you think it took so long, and what could funders or researchers have done to maybe make that go a little bit faster so you could have answered those questions?
Well, yes, I think it goes back to what Rachel said, that there's that disjunct between you know, science and policy decision making, where you know, there's a big lag between an issue and a response. So I think that's what we need to shorten. We need to kind of shorten that time and get there. And I think the other thing that would help us solve also this issue of effective adaptation, it would actually fall in that realm that, for example, and I can take Lodwar Town as an example where we worked. We had absolutely no data, not only us, it just wasn't there. So we provided that data, and from that data, we're able now to say, this is a potential climate resilient pathway that you can follow. That came out of that. So we have generic ways in which adaptation can be put in place, and I guess where there's no data, that's where we go, and that's where we begin. But it's also an opportunity to get data. So for this adaptation finance that we're all targeting, that kind of element should be there for data-sparse areas or situations that we're working in, pulling through all along to action on the ground at the end of the day. I think that's important. And then just to quickly react to two things. One was, she mentioned about this expert opinion. Now, I remember that there was a group of geologists somewhere in Italy. Earthquakes were happening, and then they were told, tell us, you must say something. And the expert opinion was from all the data. And they used the best, you know, they took the best course. And I would have said the same thing. They said, now, from this behavior of these seismographs, we don't expect any earthquake to happen. So they didn't evacuate the town. Next day, boom. And these geologists were thrown into prison. So, yeah, and it took 2 years to get them out. So I think this is one of the reasons scientists are very scared about, you know, giving expert opinion and getting flagged for it. So there should be some kind of protection. You know, we're saying this is expert opinion, but we are operating in deep uncertainty because of climate change and how it's going to vary. No one knows it. None of us is a prophet. But from the best science that we have today, this is what we can say. So don't pin us down for honesty. But take that as it goes forward. And then the benefits of planning ahead. I traveled with a gentleman who was a member of the Chinese National Academy of Sciences. And he told me they had a 50-year plan, 100-year plan, and a 200-year plan. Now, these are the kind of timescales that we are planning for in terms of climate adaptation, climate resilience building, etc. And we shouldn't shy away from it. And in fact, having those long targets help us to accelerate achievement of shorter-term targets much faster than we would if we're just focusing on the shorter term. So in that sense, we need to go beyond that election cycle and not shy away from it, but just try to pull everyone along as we move forward. Thank you.
Thanks.
Great, and now we might do something completely different, which is to question how we see ourselves as researchers and the work that we do. I would like to invite an intervention from one of the social researchers in REACH, Dr. Marina Korsanevica, to ask our panel a question.
Thanks. I really enjoyed the panel discussion and especially how many different opinions and projects were happening. And I really liked this notion that we need interdisciplinary research as well, because I feel it's very important. I would like to reflect a bit on the question by Professor Alago about the sufficiency of data. And I would also like to bring further sufficient data for whom? Where do we position people in shaping the science? How can you reflect on the power relations in building climate science and inclusion of vulnerable people who do struggle for climate variability or climate change? So broadly, if some of you would like to say more about how can we move climate science more towards decolonization, inclusion people, and shaping the research agenda and being part of the design and to also value the knowledge in climate projections, perhaps. Thank you.
That's a difficult question. We don't have very long, so if you could keep your responses to that
Maybe
as brief as possible.
Please wrap your final reflections up into that response as well. That'd be great. Who would like to go first?
Okay, I will go first. And I think I picked the word decolonization of research. And I think awareness and acknowledgement is the first step. Do we know that our research is, and to what extent it is colonized, so to speak? Are we aware that, for example, and I think within the research community, most of us are, that if you fund my research, you have an agenda. And a lot of the times, the agenda may not align with what my priorities are or what the needs are. So first, acknowledging that there are various ways that research can be colonized, and then asking ourselves, do the funders want to change? Do we want to change? Are we willing to listen to the local context? Are we willing to listen to the people we are funding to co-design projects that meet both our needs? Governments in Africa, for example, have priorities that may differ from what the funders would want to work on. And an example is push for mitigation action, while for a lot of African countries, adaptation really is the immediate priority. So can we work on research that has co-benefits? So you gain and we gain. And I think that's what I would say for now.
Opening up to any responses.
Yeah, okay. Thanks for asking us the difficult questions. It's so important. I think completely agreeing with what you said, Patricia. I think around the question of decolonizing research, it's just so important that we really support and really pass the leadership to our African colleagues, including both researchers and kind of practitioner institutions, governments, to really take the lead. If you look at how many people there are in the UK working on climate change science, climate change adaptation, and compare that to the whole African continent, it's just boggling. And hearing all the different challenges that we mentioned that need to be addressed, there's so much work to do, and I think we're never going to address all of those questions if we don't really support early career researchers and research leaders in African universities and African institutions to really grow that body of expertise and support those who are already doing such amazing work. So I see that at the research level as really important. And I think that in terms of working with and understanding the needs of those who are on the margins, I think that I also have a lot to learn from my African colleagues, and this new palm trees project, which Wilfried, who was going to be on the panel, and Ellen and our colleague Babatunde Abiodun in Cape Town are co-leading. It really focuses on trying to address this question of like how to understand climate extremes and how they impact those on the margins, and also how to build resilience for people who are living on the margins.
Thanks. We have time for one of you to respond, I think.
You go ahead, Ivor.
Okay, so just to respond to the issue of sufficiency of data and for whom, we already know the problems that we have with insufficiency of data, but I just wanted to raise the issue of what we can now call new data, like, gender disaggregated data. I mean, we've been talking about this for a long time, but I would consider it as new data. And I think in terms of water security, it is extremely important. Many studies have shown that. We have reported it in the IPCC, so it's not only about gender, but also about boy and girl and all that. That data is extremely important. The only key thing is how then can it come out of these programs, and I like the demand that funding agencies are putting that it must be a component, but how do we bring it then to the policymakers to sit and weave it and weave this information into the planning that they have, for example, in the water sector, in their policies, in their strategies, and in their plans. That is still an open challenge, and it's something to look into on the basis of the new data we are getting. Thank you.
Louise, we might give you the last word.
Oh, okay, thank you. Yes, I mean, I fully agree completely with all of the panel members' interventions. Certainly, within CLARE there is a real and deliberate focus, on integrating, for example, gender and equity issues, and that's required by all projects. CLARE also contributes to things like the Adaptation Research Alliance, which, to come back to your question around like who is shaping the research agenda and what questions, are being answered, what priorities are being funded. One of the ideas behind the Adaptation Research Alliance is to kind of bring more balance and more voices into that discussion. And then I guess as the very, very last word, in terms of the, question around access and whether that's, the ability for policymakers to actually integrate new information, like you were just saying, or, access to new data sets and things like that. I think this again comes back to real and genuine and authentic capacity strengthening activities, both on the research side as well as on the practitioner side as well, and that has to be via a partnership, an equal partnership.
Great. Thanks everyone on the panel, and thanks everyone for asking a question. There have been some lovely themes explored today around sustainability and collaboration and partnership, all things that take time and money and things we need to focus on going forward, and we've learned a lot about in REACH. So now I'm going to ask Rob Hope to come up and close this session and tell us all what's happening next.